All right. Good evening, everyone. Welcome to Kopernik Observatory's live stream, maybe on the conjunction of the Moon and Mars, which includes a occultation of Mars as well. So the conditions up here, as we updated you in the chat, are pretty mucky. I don't expect much of a clearing based on the forecast, but we'll take a deeper look into that in just a bit as we go through our introduction here. But we're going to do our best in the time we have, give you a rough idea. The occultation event starts at around 10:45 and will end around 11:10. We'll double check those times in stellarium, but it's the rough idea for our location. It will vary ever so slightly depending on where you're located, depending on your latitude especially, because that does have a parallax effect, even with an object as distant as the Moon and Mars. You will get some 3D effect there, so your position on the planet does matter. And otherwise, it is a conjunction. The conjunction's happening right now. The Moon and Mars are right on top of each other nearly. So we'll take a look at all of that in stellarium. Let's skip on over to this view here, and we'll go through our usual introduction of Kopernik. I see we have 30 or so viewers tuning in right now, so thank you so much for joining us. Prop my phone up so that I can look at the chat here and there. So in the meantime, I'll be going through my introduction of the event while we see if the clouds move along, if that's at all possible this evening. But we do have some content for you as well. One of our Kopernik Astronomical Society members and intern here at Kopernik, Sasha, is going to deliver a presentation on Martian geology. So very topical for tonight's stream. So that'll come in the next half hour or so, I expect. But let's go through some introduction points here. This is our website, kopernik.org, for anyone new tuning into the channel. And you can follow us here for all of our upcoming events. There are a couple I want to highlight for this winter season. So, of course, tonight, December 7th, we're attempting to cover the lunar occultation of Mars and the conjunction of those two objects. We are winding down here for the winter season, but we do still have some opportunities to come visit us here on site, including we have 2 showings of the Star of Bethlehem movie, which is an interesting dive into the story behind that star in the sky. You also have the opportunity to, you can come up and watch the movie. You'll have the opportunity afterwards to observe the night sky if things are clear. And this Friday, if only we could shift things a little bit, this Friday is looking pretty promising for the 9th. And I think this should be here the 16th, not the 6th. So 2 showings, this Friday and next Friday. Then we have Holiday Horizons, and that is our holiday event here at Kopernik. Special event on 2 Saturdays. So if you are local to the area, tickets are available online now. You choose the day you want, be it this Saturday or next, and you choose the time. So there are 2 1.5-hour sessions each Saturday. So you can select between 5 p.m. and 6:30 p.m. Tickets are available in all of those slots, all those windows. So feel free to tune in there. I have a second update when we talk more about Artemis. I have a tie-in for Holiday Horizons that I'll mention there. But I do want to update you on Artemis here too. So, but with Holiday Horizons, if you're wondering what the program's like, it's targeted at students in grades K through 5, so families with students in those age brackets. And we have activities planned. We have a holiday planetarium show where you get to go see what the night skies look like at the North Pole. And we have a couple of activities like our holiday lights experiments, that will inform you why you have that string of lights. Why is it that when you unplug one or one goes out, a whole bunch of them do? It helps answer those questions, and we get a little bit into electronics with that. And then we also have a Saturn ornament activity, so you can build your own Saturn ornament. And then also, so this Saturday especially is looking clear. So if you're interested in observing the night sky on Saturday night, that is an opportunity coming up here. And hopefully the temperatures remain mild here. It wasn't too bad out today, so we can have some comfortable observing coming up in this season. So holiday horizons, I'll mention that again in just a bit. But Kopernik will be all decorated, and it'll be a lot of fun. And we'll be doing some giveaways there too, which again I will mention when I talk about Artemis. So down below, we'll take a look at our clear sky chart. Let's see what we have to work with tonight and what's coming up. So if you don't know the clear sky chart, this is what we use to monitor our local conditions as they relate to astronomical observing. And what you don't want to see here is white. These bright whites here. I would even take a light blue block at this point, but not even those are showing up. So the top row is for cloud cover. This is another cloud cover model, the second row here. And both are bad. So that does not necessarily bode well for us. The transparency and seeing are also extremely, extremely poor. So and from what I've heard people mentioning in the chat from where they are, there's a lot of cloud coverage across the states at the very least. So maybe we'll try and dive into where maybe there's an observatory that will clear up at some point out there, and we can enjoy this together. But it sounds like we've had some pretty bad luck across the board here for tonight. And even for the opposition date tomorrow, one cloud model is saying it might be clear, but either way, the transparency and seeing are going to be poor there as well. So yeah, even Friday and maybe Saturday too, the seeing isn't great, that's a measure for clarity, especially as it relates to planetary bodies. So ideally, that would be dark blue, and conditions would be great for observing Mars and the Moon, but not as of right now. Looking not great over the next week. Do keep in mind with this Mars close approach and opposition, it's going to be still pretty close to the Earth for the coming months. It'll still be fine to observe Mars and get some good images of it and some good visual observing with the planet. But yeah, in the next 6 months or so, as it starts to drift away and it becomes more apparent, then yeah, it won't be as nice to view. But in the next couple months, even if you don't see it this week, it'll still be almost as good following weeks. And perhaps you've already noticed it in the sky, a nice bright red star, but it's not a star, it's Mars. And I'll show you exactly where to find it in Stellarium. Okay, but yeah, Friday, if you're able to come up to our site on Friday, and maybe we'll have some good skies then, and Saturday as well for holiday horizons. So that's our clear sky chart. Now, let's see here. I'm going to bring this over here first, just a second. Oh, and we'll minimize this. Because I just need to bring up our YouTube channel here. There we go. Okay, so here's our YouTube channel that you found us on tonight. And the Lunar Occultation of Mars is streaming now. That's what you're watching. But you also have a bunch of other videos to choose from, some that have been just directly uploaded, but a lot of our content is live stream based. I mean, that you can come over to the live stream tab and see what we've done. Most recently, we did a update on both the James Webb Space Telescope and the Artemis mission, Artemis 1 mission. Lots of progress happening with Artemis over the last month since its launch on November 16th. And by the way, we did cover that. The launch of Artemis 1, I covered that from home, there I am. And that is one of our Kopernik reaction streams, our KRXN streams. So that was November 16th. I wasn't certain it was going to launch. I don't think anyone was, really. But it did. It went off, and it was a near perfect launch. They have some redundant engines built into that rocket, and all of them fired. Nothing cut out. So, and so far, I think the only thing I've heard of that Artemis 1 has faced, the only issue, is that they had a communication drop and they had to reboot the system. But that's not that abnormal for this style of spacecraft. So they rebooted and everything was fine. And we'll talk more about that in a moment. We'll take a look at where Artemis 1 is. But yeah, this covers a range of topics. You see, we don't just discuss astronomy. We dive into other areas of STEM, and one of those more recently is a stream about dinosaur artifacts, which was very informative, delivered by a local professor from SUNY Broome, one of our community colleges nearby. And his name is Professor Bruce Oldfield, and I definitely recommend jumping back to that one if dinosaurs interest you. We also talked about weather with this big snowstorm that happened in our area in December of 2020, and the meteorologists that delivered this presentation discussed also what this winter would look like. And even though we're not quite to winter yet, a lot of their predictions seem to be coming true, with a more mild winter, with definitely you'll have some ups and downs, I think was the general summary of their discussion there. But you can go back and watch that one too. So, like I said, we won't be in the winter season because we wind down a bit. There won't be as many Friday Night Live programs and those presentations there. But we will still try to bring some live programming and video content to our channel over this winter period. We'll try and get some more night sky lives out there for you, and there's some potential meteor showers, and of course there's also just a lot to see in the sky. And it's been a while since we've done a generic live stream on just what's out there and just bouncing around to different planetary bodies. And while we have Mars so close to the Earth at the moment, near opposition, I do want to take an opportunity to try and image Mars, because there are the picture in the thumbnail of this video, both of those were taken here at Kopernik. The moon, which is the overgrown moon there, it's supposed to simulate what we'd be seeing tonight through a telescope. But the picture of Mars was also taken here. And there wasn't much in the way of a polar ice cap. But now there is, because we're in the right season for it. So it would be cool to get some good images of Mars in addition to Jupiter that's out there, and some of the deep sky objects too, like the Orion Nebula. That's always a great object to image and even to view live through a telescope. So we have a lot of new audience members that we've gained over the last year, and I think it's worth diving into some of those other objects, the ones we haven't really focused on too much. All right, so that's a little update to what we have going on here on our Kopernik Observatory channel, what we can look forward to in the coming months. Our FNL, our Friday Night Live streams, will resume every week starting in March. But like I said, we'll have some intermittent ones here in the winter season. All right, so let's jump into this NASA EYES program, because this is how we're going to talk about Artemis. And NASA EYES is a great simulation that can run directly on in a web browser. I believe they do still have a way to install it, but it works pretty well on your web browser. So you can just come to this link here, eyes.nasa.gov, and you can click Eyes on the Solar System. So I already have that loaded up here. And it's a great way to look at the solar system, and you can travel through time like usual, some of these programs. But it's also a great way to track NASA missions. And right at the top here, they have a way to fly along with Artemis 1. And for those that are not aware, Artemis 1 is the mission that's carrying the Orion spacecraft. It carried it to the moon. It's been in orbit around the moon. And it will soon be coming back home. In the next few days, on December 11th, it will land back here on Earth. It just completed its last close flyby around the moon. And let's take a look at where it is. So there's the Orion spacecraft. It's not if you saw the rocket launch, and you can go back to our stream to watch that live with us. It was this sort of an orange rocket with some boosters on the sides, and that's called the Space Launch System. But this is all that's flying out in space now. It's just the capsule, the spacecraft bus, and the solar array that remains. And this capsule is the Orion space capsule. And that is what will eventually carry astronauts back to the moon for the first time since 1972. So, yeah, I think, yep, you can fit about a crew of 4 in the Orion space capsule. So it gets a little bit cramped at that point, but it can support 4 astronauts. And let's see if we can pan around here. There it is. Got some pretty decent sized windows. There's 4 of those. 1 for each astronaut, right? Got some good logos on the sides. There's those panels, the propulsion system. So we'll be going back to the moon. This will become a crewed spacecraft, starting with Artemis 2. Now, with Artemis 2, they won't land humans on the moon. That's Artemis 3. But just like Apollo, they go step by step. They test the spacecraft without people, then with people, but not doing the landing procedure yet. And then Artemis 3 will finally be touchdown. And we'll see how delayed they are, because Artemis 1 was delayed a fair bit. At one point it was going to launch in August. But because they had some issues with the Space Launch System, it got delayed all the way out to November 16th. And it was a very, like I said, very successful launch. But yeah, it was delayed. So we'll see how that affects the future timelines. Last I heard, it was 2024 for the Artemis 2, and then 2025 to 26 for Artemis 3. So we'll see if that timeline holds at all. But like I said, very successful and very exciting to hopefully in the next few years we'll see astronauts land back on the moon. But speaking of the Orion capsule, tying back into our holiday program here, Holiday Horizons. And by the way, this is a slightly photoshopped image of the domes at Kopernik. So traditionally on a Friday night, we have red lights all over. Those help maintain your night vision. But you can see this, I just recolored this dome to be green, so we get those holiday colors. And we talked about what Holiday Horizons was. It's an in-person program. So if you're non-local, I apologize, we won't be able to celebrate with you entirely. But if you are, you can purchase tickets online. And like I said earlier, we are doing some giveaways during Holiday Horizons. For those in attendance, every family is going to receive a mini Orion space capsule ornament. So just the capsule here. You can go home, take that with you, and you can decorate it. So it's about an ornament sized for one of those tabletop mini trees. So you can, of course, put it on a big tree too. But for one family per session. So we have 4 sessions between the 2 Saturdays, and one family per session will win one of our larger scale Orion ornaments that we've decorated here to closely match the Orion space capsule, and especially the version of it that lands back in the ocean on Earth. So I'll show that to you. This is a little preview, and it's not 100% finished, but I'd say it's about 90% there. So all we have to do is pretty much add the ornament hardware, so to speak. So let me hold it up to the camera here, and you can have a preview of our 3D printed Orion spacecraft. It's not showing up too bad there. So we have some detailing on the propulsion systems that direct it on its return, and even in space. Those propulsion systems help guide it. Those are those black dots, and then the windows. And you can see we do have the NASA logo and United States flag. Rotate to the back. We have a couple of other details here. We have the Artemis logo. So that's the logo. If I get even closer, you'll see it. That's the Artemis logo, showing you the blue Earth. That's that streak across the bottom. And then the red line swooping through the A is the pathway to Mars. And then if you look very carefully, that pathway of Mars starts with the moon. Well, starts with the Earth, then goes to the moon, because that's what Artemis is about. It's about getting back to the moon first as a pathway to Mars. And then on this side here, the last detail, it's a little out of focus, but you can just about see the Artemis 1 logo. And the Artemis 1 logo, let me see if it'll adjust. Come on, focus. Maybe I can control this here. Let's see if I can. Oops, it's just falling on me as I lean on it. Let's see if I can. Manual focus. There we go. So you can see the little rocket there, the SLS. So that's the Artemis 1 mission, strictly about testing the overall system. So this is perfect for a full-size tree, and it's a. Oh, I forgot. I gotta calculate out roughly what the scale is. It's somewhere around 1/100th scale, but I'll double check that. Might be closer to 1/50th scale. And like I said, this is where we saw in, oh, you know what, I should show you in the bigger view. Let's do that. There you go. So I'll rotate it around once more so that you can see in the bigger view. When we were looking at the capsule in the animation on that Eyes on the Solar System, it is capped. This is uncapped, because that's where, when it comes back to Earth, that's where all the hardware for landing comes from. So that cap gets blown off, and then it has parachutes to help it land softly into the ocean. There you go. So, like I said, one family, we'll do it like we're doing it like a raffle. So you'll get a ticket upon registering at the front table, the check-in table, and then we'll do a drawing at the end of each session of Holiday Horizons, and one family will go home with it. To give you a sense of why that is, why we only have about 4 to cover the 4 sessions, that's because on a 3D printer, this takes about 8 hours to print between the 2 parts. It's got a lot of intricate detail here, and it makes it a little bit of a challenge to print out. But you have enough to at least support 1 per session. So if you can join us for Holiday Horizons, that's a sneak peek at what you might be able to win. And like I said, we made a bunch of smaller 3D printed models that every family will go home with. So either way, if you attend Holiday Horizons, your family will go home with an Orion ornament in some form. All right, so I thought I should, again, we're doing a little bit of hand waving here while we wait to see if the conditions improve at all for us here up on the hill in Vestal, New York. It is pretty cloudy out. So we'll do our best to try and cover the event, but we'll have to blow these clouds away, I think. So let me switch back to the presenter view and get back on topic now. That's pretty much the end of my introduction of Kopernik, but I do want to show you Stellarium here with the, oh, there we go, yep. I just want to show you the event, what we're actually looking for in the sky. So here's the sky as it is right now. Stellarium can be downloaded at home on your personal computer at stellarium.org. And if we look at it here, this is the web page where you can download it for Linux, Mac, or Windows. And there's also a web version for mobile devices. There's even a mobile app that you can download in either app stores, and a use for Chromebooks as well. So, I just took a look at the chat here and noticed Jackie's asking, back to the Artemis topic, will Artemis show some awesome pictures once it comes back? And it has delivered some imagery. I wonder, why don't we go to nasa.gov? I know we're bouncing around here, but this is going to be a very informal stream. I should have prefaced that to some degree. Very informal tonight as we try and capture the event. So let's go to missions here, Artemis 1. You could see that there was already one picture up front there. But let's click through some of these to show you the real imagery that came down from the Orion spacecraft system. So this says Orion approaches moon before return flyby. So it did one more flyby recently on its way back. And there's the Orion space capsule, the spacecraft bus, and a solar panel just right there, like we saw in NASA Eyes on the Solar System. Here is one of the higher resolution shots of the surface of the moon, showing you some of the craters as it flew by. Now here, there's a couple that I really, really like. I mean, this one's set as my phone background right now, just because of how brilliant an image it is. You have the Orion spacecraft again, the spacecraft bus, the support module, and you have the moon and the Earth. The Earth is just a touch smaller than the moon there, but you can see this is one of its further out flybys. So actually, for a spacecraft designed for humans, Orion hit that record. It went beyond the Apollo era, and granted there was no humans on board this time, but it will make that run with Artemis 2, and at that point it will hit that record. So what's cool about this too is you have both objects roughly in the same phase, sort of a gibbous Earth and a gibbous moon. And let's click through here. Next one. Oh, go back. So there's another sort of close approach flyby of the moon. We have some images of, that's not a real image, mind you, but that looks like one of the CubeSats that launched. It had about 10 CubeSats. And let's see what else. There was another one more recently. You know what? Let me show you. If you want to know a good tip for finding NASA photos and downloads, this is not the place to go. NASA is updating their website, and it should be a little bit easier to find this stuff, but there's a place you can go called NASA, I think it's NASA Media Gallery, something like that. NASA Image and Video Library, I think that's it. Yep. So this is even better because this allows you to search, and it'll give you some really recent images. Is this the one? And you can download them directly. Let's see if this is. Yes, the crescent Earthrise. Let's watch this quick. I know we were going to get into Stellarium, but then we like to drive our streams on questions, so I think this is good. So this was the Orion spacecraft in orbit around the moon, and it is a crescent Earthrise. And one of our science educators here who gave a presentation last week on Artemis and James Webb, her name is Tish. I'm sure you've seen her on the streams in the past. She's done a number of presentations. She reminded me that this is very kind of similar to, I think, what is the introduction to 2001: A Space Odyssey, where you have Sun, Earth, and Moon, and they're all sort of in the Earth and the Moon at least are in this crescent phase. So you can see the Moon is in crescent. Even Artemis, the Orion spacecraft, is kind of in a crescent phase too. And let's click through the video a little bit faster here. There it is. That is a crescent Earth. Crescent Earthrise. You see some solar glare over here. So just a phenomenal image there. It's great how many perspectives the spacecraft was able to capture as it traveled around the moon. So another good one there. And again, if you want to find this, go to images.nasa.gov, and you can run searches on just about any mission and find videos, audio, and pictures. And you can, of course, go up here and filter those accordingly, depending on what you're looking for. And it's just a great resource to get some really high resolution, high def content for your own personal use. And a lot of it is in the public domain, by the way. So because it's a government-funded agency, that is often the case. So yeah, I'm glad that was informative. I saw a couple people asking about where you can find them. So I'm glad that that's a good resource for you. So let's get back to Stellarium though, and talk about the event for tonight. So the conjunction of the Moon and Mars is happening right now. And if we zoom in, with Stellarium, you can pan around, look at the entire sky. It's your at-home planetarium. And if you want to zoom in on an object, you click on it. You can press the space bar to center and use the wheel on your mouse to zoom in. Of course, these functions are different or even potentially easier for touchscreen devices if you have the app at home. But this is, of course, operating on a Windows computer. So your experiences may vary a bit, but this is the conjunction of Moon and Mars. And you can see Mars is getting pretty close to the Moon at this point. I'm hearing a report from one of our regular viewers, Matambale, that microphone levels might be a bit high. So let me try and tune those down a little bit. Yeah, I do apologize that we don't have the good microphone here tonight. Let's try that. Let's see if that gets any better. In the past, our audio quality has been much better than it is tonight, but I left my microphone at home because it was still set up from the Kopernik reaction stream, and I used it there. So I forgot about it. And additionally, our things are all kind of crazy here in the Space Science Lab at Kopernik, where we stream from, because we are a new upgrade. Here's a tease for those that can attend Kopernik's programs. We're currently upgrading space science with a slew of new technologies, including some for streaming. So the streaming side of things will improve, and some just for the in-person activities here. So kind of uplifting both of those aspects of Kopernik, and we can talk more about that maybe on the next Friday night live stream. But we're very excited about some of the upgrades we're able to make. So look forward to some advancements there. So anyways, hopefully the microphone is better. Let's take a look. Less noisy. Okay, good. Yeah, I brought those levels down just a bit. So I'm not sure the audio quality. Why don't I test it out here? Hello. Yeah, I can see what you mean. It is a little bit noisy there. But yeah, hopefully that improved. Let's see. Oh, someone asked, why does every time there's something interesting going on, it's cloudy? I know it is. It is funny how good of a time we've had here with our observing live streams. Recently, we had the May lunar eclipse. We got full coverage of that event. We had the November lunar eclipse, full coverage there. We did some streams over the summer with the Milky Way, and yeah, this event, I think it was just due. In fact, it reminds me of what happened with the Jupiter and Saturn conjunction back in 2020. Yeah, 2020. It was around the same time of year, December 21st. And that one was also clouded out. And that was going to be very exciting. This one would be too, but I think the Saturn and Jupiter was even more rare than this one here. So unfortunate, but like I said, we'll do our best. We have until about 11 p.m. to try and catch the occultation. So if it somehow clears up, we'll get a camera up on the telescope and stream it out to you. All right. So yeah, we probably saw Mars get a little bit closer to the time I've spent talking here. But why don't we speed things up a bit, because Stellarium is a time machine. So, oops, let's get rid of that. Let's fast forward. See the clock moving down here from 9 p.m. I'll go even a little bit faster. You can see tonight Mars gets closer and closer to the moon. And for us, I'll slow it down here and we'll zoom in. Let's zoom in on Mars particularly. It will drift behind the moon around the southern region. So that happens around 10:45, and then around 11:10 or so, I think, is when it reemerges. It never gets very deep into the disk of the moon. But the moon will fully obscure it. So you won't see light from Mars during this period. And there is parallax involved with this. This is whereas most things in the sky are in two-dimensional from our perspective here on Earth, like when you move your head around and you don't see the stars move around each other like you would objects in a room. So this is most things in the sky are two-dimensional for all intents and purposes. But objects in the solar system, just moving around on the Earth, you do get that 3D effect. You do get some parallax. You will shift your perspective on the moon and Mars depending on where you are. You have to go quite a significant distance to see the effect play out, but it's interesting. Whereas most things are two-dimensional in the sky, things that are close by, it's easier to get the 3D effect across. So here we are heading towards 11:10 at night. And by the way, I'm reporting time in Eastern Standard Time for any of our viewers outside our time zone. All right, and we'll see it reemerge. And what's cool about this event is that, kind of similar to our thumbnail in the video, again, that's not a real direct image that I took at any point. They are real pictures of the moon and Mars, but I estimated roughly what it would look like through a telescope. And, interesting that I will see, well, you wouldn't necessarily see Deimos. Deimos is a pretty small object, but Deimos is one of the moons of Mars. It looks like it reemerges first. And then here's Mars coming out. And Stellarium is doing a good job of estimating what the caps look like at the moment. You can see the North Polar ice cap is pretty large, and it's very noticeable visually through a telescope, but also even more detail with a camera system. So, and there's Phobos there too. So yeah, that's what we're looking for the very rare event of a occultation. But a conjunction will also happen before and after. And what's driving this motion is primarily the moon. While it looked like Mars was moving there, it was in fact the moon moving through its orbit that drives that apparent motion. Now, of course, Mars is moving a little bit, but it's on a huge, long orbit around the sun, whereas the moon here, its motion is driven by its orbit around the Earth. And that's much shorter, only less than a month's time. So let me just field a couple of questions here that may have come through, and then we're going to transition to our main content for this evening. So let's see here. Oh, someone viewing from Copenhagen. Oh, very good. Welcome to the stream. Oh, Michael asks, it's cloudy on Mars. So Mars does have clouds. They aren't thick like Earth clouds here. They're really wispy things that exist in the Martian atmosphere. Mars does not have much of an atmosphere to begin with. So you don't have major weather events like you do here on Earth, with the exception of some high winds. Those winds do exist on Mars, and dust storms. So more often than not, you just get these little dust devils wisping around. You know, if you go to a desert here on Earth, you'll see dust devils, little sort of dusty tornadoes. Don't really cause much harm. But sometimes you get a global dust storm on Mars. And not during this close approach, but during the, let's see, the what would that have been? This is 2022, 2018's, I think, close approach. That one had a global dust storm, and you cannot see any detail across the surface. So it wasn't a very exciting close approach. Even though Mars was bigger, it wasn't that interesting to look at because of that weather phenomena on Mars itself. So no dust storm this year. That's good for us because it makes it so you can actually see some detail through telescopes. Yeah, great question. So the dust storm doesn't quite classify as cloud coverage, though. Mars does have more traditional clouds too. But not the dust storm is its own weather system. All right. Any other questions I missed? No, I don't think so. All right. So the next part of our program tonight is also ties in with the Mars opposition, the close approach, and the conjunction here. And it's going to be a presentation on Martian geology. So I will actually hop out of view in a moment here because we're going to bring on, again, one of our Kopernik Astronomical Society members, and she's also an intern here at Kopernik, to deliver this presentation, after which we will move to an intermission period. just so we can assess the skies. And if it does turn out to be clear, we got to set up the scopes a little bit. So that's the schedule for the next little bit of the live stream here. So with that said, I'm going to grab my phone and we're going to switch over to this here. Let's make sure that that gets loaded up properly. All right, we're on the right. Yeah, we're on the right one. Okay.
Alrighty, so thank you for the introduction. This is just a little presentation that I came up. It's not very much in depth on Martian geology, but it does go over some of the basics and also some little interesting things that we have learned in terms of finding evidence of liquid water that was previously on Mars. So, keep going here. So the first topic I want to talk about are some common rocks on Mars. So one rock you'll specifically find in abundance on the surface of Mars is an igneous rock called basalt. It's a very fine-grained rock. It forms very quickly at high temperatures from mafic magmas. And it cools very quickly, and that's what causes the crystals to be so small, is they don't have time to grow in these warm environments. And actually, when we ended up sending rovers and to study the surface of Mars, we found that there was actually a lot of sedimentary rocks as well. So we have shales, sandstones, and mudstones. If there are any questions in terms of the difference between sandstone and mudstone, it's more of the classification of the size of the grains that are within them. Oh, another thing I wanted to mention. So in terms of Mars's geology, why is it red? Why does it have that rusty color? This has to do with a higher iron concentration in a lot of the Martian rocks, and over time they oxidize, and that gives this little red color to certain rocks. You can see this on Earth as well. So moving on to the next topic, on Mars there are volcanoes, and unlike Earth, Mars doesn't have much tectonic activity, so we don't have those little volcanoes that can be found along subduction zones. And these volcanoes have been dormant for a really long time. As Mars cooled, they stopped erupting over millions of years ago. So if we look at the largest volcano here, Olympus Mons, it's actually about the size of Arizona. And the reason why it was allowed to get so big is due to this lack of tectonic activity. The plates aren't moving. So instead of getting a chain of volcanoes like you might be observed in Hawaii, where they move, so the magma plume ends up splitting them on multiple volcanoes. The magma plume stuck with one, and that allowed this volcano to continue to grow over time. It's also a shield volcano, so its shape is it's described as a warrior shield. And it does have these really steep cliffs on the edges here. I don't know if I can. So, trying to get a laser pointer here. So we do have these cliffs, and these are actually scarps. So they've eroded over time, and we have these really steep cliffs. I believe they're about 60 kilometers in height, but I could be wrong. Now, I wanted to get to this topic specifically, evidence of water on Mars. So I will be talking about these pictures a little bit later. Every single photo so far that will be in the presentation in terms of Mars has been taken by the Curiosity rover. A little photo of it up here. So we will talk about mud cracks and sedimentary structures such as mud cracks, cross spreads, and conglomerate rocks that have been found on the surface of Mars. So starting with mud cracks. So they form in wet environments, so there's a lot of sediments and it's muddy. And over time, they begin to dry and desiccate, which means they contract, and that forms those cracks that we see. So the picture on the right is actually from Earth. As you can tell, there's a little reference in terms of size. And all of the images on the left are from Mars. So the way mud cracks form is, at least they get preserved, is over time they will, after they form, there will be wind, and typically there's no water involved into depositing sediments into those cracks, as this would ruin the mud cracks. So sediments will be pushed in over time into the mud cracks, and this will fill these mud cracks, and then over time they will be preserved. So they will lithify and become solid rocks. And this will get that pattern where you can see these little, they're typically a different color. And what's unique about this image, as well as the one on the Martian and the Earth image, is it preserved those little lifted cracks, which is quite interesting to see as well. And what mud cracks represent is there was a significant change in climate at the time. So you go from an environment that had liquid water present, and then suddenly it became dry, and for a very, very long period of time to maybe even the present. We don't know necessarily what may have happened in between, but we know that between the time that these rocks formed, which was about 3 billion years ago, and to now, that the environment has remained completely dry. Otherwise, the mud cracks wouldn't have been preserved. And now heading into crossbeds, I'm actually going to switch to the pen. So these are a sedimentary structure that are formed by ripples, and I will explain a little bit how that works. And one really unique thing about them is we get the information on the direction of the flow. So this gets preserved in the cracks. So if we look at the right side, these are the Martian crossbeds, and here's an image I found on Google. I'm not sure where this is from, but I chose it specifically because there is a change of direction represented here. So if we look at the image, the flow of the water, essentially it flows one way. Oh, that's not working here. Okay. Oh. All right. So we have the water flowing in one direction, and it kind of avalanches over the edge. And this continues to repeat, and this pattern gets preserved. So as the water moves in this direction, that's a bad arrow, we actually get to see the directions that the sediment gets deposited in. It avalanches downwards, and it preserves that structure. So if we look over here, we can see there was a change in direction. That shows that something happened. Typically this is related to changes in elevation, but it could be other things. Crossbeds can also be caused by wind. But since these are so small, it is likely that they were caused by moving water. And I believe all of these were found in the Gale crater, and which they found a lot of evidence that there was water in this crater as well. So if we look here, we can also see the same pattern occurring here as well. So we can actually see the direction that the water was moving in. Now going on to conglomerates. So some of you might have seen these around. It also happens at beaches and rivers and creek beds. And from my understanding, they believe that this image from Mars was actually from a creek bed, which is quite interesting. So the way conglomerates form is there's typically running water. An example that's used a lot is Mountain Creek. I don't think that's likely on Mars, but in terms of deposition, these pebbles get carried. They're about over 2 millimeters. So something classified as a pebble is over 2 millimeters in size. Sometimes they can get really big. Conglomerates can form with big rocks, and they're specifically rounded pebbles. If they were angular, it would be called a breccia. So when we're looking at conglomerates, they get deposited in an area, they get compacted, and then there's typically some kind of substance that cements them together. This can be other rocks. It's kind of like a gluey cement that forms naturally. So we can tell that on Mars there's rounded edges, which suggests that these rocks were being moved by something, and they were abraded by hitting other rocks, which gives them this rounded edge. And they were eventually compacted and cemented together, and they believe that this has occurred due to these rocks being in running water, which demonstrates or provides evidence for there being water at some point on Mars, which is very interesting to learn. And ultimately, it provides us more things to look into when we do get to Mars. So hopefully with the Artemis mission, this will be very possible in the future, as well as I believe NASA is cooperating with the European Space Agency to pick up some of the samples taken by the Perseverance rover, which landed last year. So a lot of really exciting things moving forward. This is the end of my presentation. I will check if there are any comments, and if I miss any, I will check them later in the chat as well. So, okay, that sounds good. So we'll be heading over into our intermission, and we'll get back to you in a little bit.
All right. Hello, everyone. We're back, and unfortunately not back with any telescopic views of this event. Not just yet. Possibly not ever, based on how uniform the sky has been throughout the duration of this stream. I will say there are some good streams out there to tune in on that do have clear skies. Let's see. I think the best one right now that I've seen is Griffith Observatories. So if you want to see a nice telescopic view of the event, venture out over to Griffith. I believe they're based in Los Angeles. And what's cool here, though, for the streams that are speckled around the world covering this event, for those that do have clear skies, it's kind of cool to jump around between the different ones and see how far along the event is compared to how far along it would be for us here. In fact, for us in New York on the East Coast, it hasn't started yet. But we saw there's a stream happening in Texas, and then there's Griffith Observatory on the West Coast, and the occultation is underway. Mars is behind the moon, transiting behind it, and so it's kind of cool. You get to see that parallax effect play out, and I think that kind of shows the power of these live streams. Is for a dynamic event, heavily dependent on location, you get to compare between the different views across the world. So check that out. Check out the different aspects, compare it back to any simulated views you're viewing where you are, or if you have clear skies, even better. I saw a couple of people mention that they had clear skies where they are. So let me come down here and bring up our comment section, because I will open up the comments to some questions. I see while we were in intermission that there were some good conversations happening, and I saw some requests too, for like Linda here, for example, hoping that we do cover some Mars observing in the near future, and that is in my plans. I mean, it's probably going to be a sudden stream that just drops when we have clear skies. So just be on the lookout. Click the notification bell on our channels that you can be alerted to those drops, because we are constrained by the sky conditions, of course. So for the events where they're not specific, like this one, the occultation has a specific time, and if you miss it, you miss it. Objects that are out in the sky, like Mars, throughout the duration of this season, we can stream anytime it's clear. So just click that bell to be notified for those streams that do drop. So those would be our night sky lives, like this one. Now, I do want to sort of do a retrospective on the previous opposition of Mars stream, because that's kind of what this one is. Technically, the opposition is tomorrow, but we're close enough that it wouldn't be too different viewing Mars. And on top of that, this is the more exciting day. Unfortunately, tomorrow also doesn't look good. So we'll get as close to opposition as we can for Mars observing for this year's This Close Approaches live stream. But I do want to take a look back at our previous one. So earlier we talked about how in 2018 that close approach was totally covered up by a dust storm happening in the Mars atmosphere. So there wasn't much to see, just a dust ball. In 2020, October of 2020, we did get to observe Mars in a good amount of detail with our usual rig of a ZWO camera, a planetary camera, hooked up to our 6-inch superplanetary refractor telescope. So I'm going to jump in here, but first I'd like to show you how you can find it if you wanted to go back and click through it yourself. And doing this, trying to hunt it down, it made me realize, wow, we've covered a lot of astronomical events, and just in general, I've run a lot of live streams on a variety of topics. So let's scroll down and find this. So this was, we've been streaming for a while now. We started in 2020, and this was early on. This was back in October. Okay, so you scroll way down to 2 years ago, and it's kind of funny. You can kind of see how our channel evolved as time has gone by when you do this. But around this time period, we were still early days for our Night Sky Live programs, but we did lunar imaging. We did some planetary hops where we would observe the Moon, Mars, Jupiter, and Saturn there. We did some deep sky streams. This one is an image of the Trifid Nebula there. And here we have the opposition era of 2020, where we had the close approach of Mars, the opposition of Mars. These were all probably within the same week. And then we had some really good seeing on November 8th of that year, which was a little past opposition, but we used it as an opportunity to get some clear images of the planet. And if you really want to have a laugh, I guess, you can go back to our Halloween stream on the full moon. There was a full moon on Halloween back in 2020. And of course, I had to come in costume. So if you can go jump to that. It was we called it a spooky stream on Halloween, and it wasn't me that was there that day. It was Kylo Ren. So you can have some fun watching that too if you want. But anyways, let's take a look at the opposition of Mars. We'll click on this here. And we don't have to hear that part. I'll just mute the video. So now we can click through and kind of show you what an approximate view of this would look like, at least of Mars during opposition. And again, no dust storm here, so you actually do get detail. And if I take a look at, let me take a look at the thumbnail, because I can't remember if this one came from. If we click through, let's see how, if there's a geological feature on Mars called Syrtis Major. And the reason I bring that up is because in this video's thumbnail for this stream, the picture of Mars that we took here that's in the thumbnail, it does show Syrtis Major. So I'm trying to figure out if that image came from this stream or not. Yeah, it might be over here. But also we did a bunch of Mars streams during this time, so it could have come from one of them as well. Mars has a 24.5-hour period of rotation. So it's just a half-hour longer day than here on Earth. And because of that, day to day, you'll even hour to hour, you'll notice some changes in the geological features. Some will rotate into view, some different ones. Now, here you also don't really see any ice caps. That's a big difference from what you'd see now in a scope. There would be a large, like we saw in Stellarium, a large polar ice cap in the north of Mars. And that's driven by the seasonality of the planet. You get a winter and you get a summer, and that causes those ice caps to grow and shrink. Kind of like they do here on Earth. It's a very similar process. So now keep in mind that this is a live view of the planet directly through a telescope, and it does look a little fuzzy. And part of that is the conditions of the sky, but also part of it is that it's still a small planet and it's still pretty far away. And what that altogether causes is you get a little kind of like a fuzzball with some some surface detail, some contrast zones. Now, of course, a larger, more powerful telescope could do a bit more. And in New York, we can occasionally have some decent seeing and clarity in the sky, but more often than not, it's a little bit turbulent. And because of that, our clarity on the planets is slightly diminished, in some ways dramatically diminished from what you'd see. But you can see occasionally the atmosphere stabilizes a bit and you get some better clarity. And what you do with this, you take a recording of the object, and this is where the picture in the thumbnail came from. Take a recording of the planet using your planetary camera, or even I've done planetary imaging on my phone before with a phone mount with a telescope. And you just take a video, and then you take those frames from the video, select the best ones, and this is all done in software. The software I use is called AutoStackert, and it selects the best, highest clarity frames, and then you stack those frames to pull together as much detail from that video as possible. And that's how you get a high detail image of a planet. And it works for most of them pretty well. Anything with good surface detail, stacking is well worth it. So, and you can see that effect play out in the camera view here, where you occasionally get this moment of clarity in different regions as the atmosphere stabilizes and then it disrupts again. And it's those moments that both visually and for imaging, those are what you're seeking, where you have those brief points of clarity. Oh, Lorna says they remember that stream. That's cool. It's cool to see how our channel has grown over the years, and we have viewers from all that time ago when we first started live streaming like this, and we've continued to grow too. And I know some new viewers are tuning in tonight. So, and we wouldn't still probably be doing this without your support. So, thank you for helping us grow and communicate this wonderful field of astronomy to you. Yeah, you can see this is early days because I have Kopernik Astronomer will return soon, and then I have some rolling text over top of that. I didn't think to move that. But hey, you know, even today I still make all kinds of mistakes. But you can see in the webcam view in this video, let me full screen it so it's a little easier spot. You can see the 6-inch telescope in that video feed. And this was also back when we didn't have a nice comfortable setup inside, sort of a remote streaming setup. I just zipped up my coat there because yeah, it was, even in October here, was a particularly chilly day. But always well worth doing. It's just now that I can be comfortable, I choose to be. And you don't have as much chattering teeth coming over the microphone. So yeah, if anyone has any questions, I'm happy to answer those related to any topics we've discussed tonight. I do want to mention, if you are enjoying the stream tonight, or you just would like to support Kopernik, we do have a year-end fundraiser going on now to close out the year here. So that is available in the YouTube chat itself. So you can click the heart and you can donate to Kopernik there, or you can use the PayPal link if that's preferred for you. You can use the PayPal link in this video's description. Both are good options, and on both those platforms, all the proceeds go to Kopernik. We are a nonprofit organization, so your kind support helps keep us around, and we thank you for that. come back to this in a moment if we like, but let me bounce back to and again, for anyone just tuning in, the video we were showing is not from this year. It is from the last close approach that we covered in October of 2020. So let me bring up Stellarium. We'll see what state it's at in our sky. Again, if you jump to Griffith Observatory, in fact, oh, actually, Griffith. I don't like to show other channels' content on my stream just because they kind of lose out on that. I prefer you click on their video and support them. So instead of me showing it here, jump over to Griffith because I think Mars is about to reemerge not too long from now on their stream. For us, the occultation has not happened yet. Mars has not passed behind the moon yet. But for Griffith, I think it's just wrapping up. So let's see. Oh yeah, yep, it's passed. It has moved out off the disk of the moon. And you can see, oh, they adjusted their view too, so they're using more of a planetary cam setup. Last I checked, when Mars was behind their moon, it was a more wide field view. And I was hoping that they would switch to a cropped view with a planetary camera, and that is exactly what they did. So it looks like they're exposed to Mars on their stream. Again, if you want to see what I'm talking about, just go ahead and open up Griffith in another window. But yeah, they're exposed to Mars, and the moon is a little bit overexposed. In fact, I don't think I see any crater detail. Maybe a little bit on the very rim there. Might be a touch of contrast, but yeah, this is the trouble with this event, is that they do have slightly different. They do. I can't remember the exact magnitude, but well, we can find out here. And right now, Mars is at nearly a -2 magnitude, which is really bright for Mars because it's at close approach. And the moon has, obviously it's much brighter, it has a -13 magnitude. So basically an order of magnitude larger. But yeah, it's a nice, it's pretty awesome to see Mars and the moon in the same field of view. Sasha, have you come across any streams where they've got the exposure levels a little better?
Not sure, aside from Griffith and that rays.
Rays?
Yeah, it's the one with the purple.
Oh, right. Yeah, let's see what they... Again, I think it is, the streams like this are few and far between tonight because conditions are pretty cloudy almost everywhere, at least throughout the states. Let's see.
It's no longer purple.
Oh, it's not purple?
It's bluish.
Oh, okay. Did there? I forget. Did we figure out where they were?
Austin, Texas.
Austin, Texas. Yeah. Okay. So there's.
No, it just disappeared for some.
Theirs probably has ended. Is it Ray's astrophotography?
Yes.
Okay. Oh, it did disappear. Huh?
Mm-hmm. Might be clouds. I know they were struggling with
Interesting.
that. Oh, it's going to.
Well, that one might be another one to check out. I think that's Ray's astrophotography. They have a moon that's coming in and out at the moment, but might be worth diving into because it's kind of not quite, but almost midway in between where Griffith is and Kopernik Observatory is, more south. But so yeah, it's cool to see these different perspectives, and I'm glad it's clear somewhere out there, so that we can enjoy it too. Let me bring Griffith back up on my view here. Oh yeah, they're adjusting their view now a little bit because so that they capture Moon and Mars. Very nice. They have pretty decent conditions there. You can see some contrast on Mars for sure. I want to take a closer look to see if you can see the cap. Oh yeah, definitely. Just like I showed you on our previous stream, you'll see the image come into a nice point of clarity during those windows of a stable atmosphere, and when you get that, you can see some of that white of the ice cap. Very good. I'm going to bring up this here first just a second. I'm going to bring it off to the side so we can get back to our stellarium view. I just wanted to pull up the chat on the computer now so I can read this out here. Yep, so what time is it? It's 10:42, so in the next 3 minutes or so, if you somehow have a clear window anywhere near us, then yeah, head outside and try and see if you can see this, because the Mars is about to disappear, and then about 20 minutes later or so, it will reappear.
So Nevada desert skies.
Oh,
There's just
Nevada desert skies.
reappeared.
Oh, okay. So theirs has ended then, probably too, right? Yeah, because they're further west. Cool. Nevada desert skies is another one that you can check out with where you see that conjunction. Their occultation has ended as well, but you can see the conjunction. I want to look that one up because I want to see how clear that is.
They're also using a ZWO.
Oh, good. Nevada desert skies. So out in Nevada, they should have some really decent skies. Very cool. I'm going to have a quick peek out the side door here, see if anything has changed. Good.
There's also the ranch from Lunar Library and Observatory, and I think they just ended their stream, but they have
Ranch. Oh, they have a lot of good views on there. That's very nice. Oh, I like this view at the dome there. That's clever. I like that. All right. Okay, so yeah, not clear for us, and it's so maddening because you go out there and you see the moon glow, but it's diffused all across the sky because of the cloud layers. And it's just, you see that evidence, it's happening. It's just behind the clouds. But yeah, you can't access it. But yeah, like we said, there's loads of options out there where they do have clear skies. So go check those out. Check back in at Griffiths here. Looks like they've moved on to just a Mars view. And that might be because it's just moved too far away from the disk at this point. But maybe not. Maybe it's just they have to adjust it. All right. Oh, I see. I just noticed that we have 99 likes. Would anyone like to hit the thumbs up button to bring us to 100 for this video? It does help show your support for Kopernik. Oh, there it goes. Thank you. Thank you so much. All right. So let me gauge the chat here, because we do still have a good amount of people tuning in to our stream at the moment. As far as the views that I've shown to this point, we've been watching it on Stellarium. That's what we're doing right now. I can also switch back to our previous Mars opposition stream, the one from 2020, if you just want to see what Mars can look like through a telescope. Again, I'm also open to questions if you have them. There is another thing I want to show you too through NASA Eyes that shows you the power of that tool for education. So I'll show you that eventually. But let me know your preferences here on what you'd like to see on our stream. I think during the duration of the occultation, I think it makes some sense to just watch this play out, even though it's all simulated for us here. Given that the conditions are cloudy and they're going to stay cloudy, I do not intend to keep the stream going much longer after the occultation event, because there's just no chance we'll get to enjoy Mars tonight, more than likely. So we'll postpone that to another day where we have much clearer skies, better seeing conditions to see this close approach of Mars. But I want to do at least one stream with that. I think it's well worth it. It's always fun too, because during the stream we'll take the videos necessary to go through and process Mars and get a good image out of it. And like I said, there's some new features like the polar ice cap being nice and large at the North Pole that it will make for a very different photo in our library of Mars photos here at Kopernik. Oh, it looks like Griffith ended their stream. I guess if their occultation is over, that makes some sense. Yep, I guess their stream is ended. about the rays one? Let's try that. Oh yeah, Rays also ended their stream. And again, because they're further west, so their occultations have already played out. Ours is just starting here. But the Griffiths occultation was pretty cool because it went deeper into the disk of the moon. So it took a longer amount of time for Mars to pop back out. But it is underway for us somewhere behind the clouds out there. Now, our weather conditions, I think throughout most of the stream, up top in our live stream, we have the date and time, and we have the weather conditions. And yeah, it said mostly cloudy for a good duration, and they showed a little moon there in the icon. I can't say I've ever seen any inkling of clear skies out there, so it's too bad. We've actually had some pretty foggy conditions up on the hill here, so that's been an issue. Though some of that, when I just went out, it's dissipated a little. It was pretty thick before. Now, this does open up some talking points for the Artemis missions, too, because for us, it's roughly passing through the southern region of the moon right now. And I should emphasize that, of course, Mars and the moon are millions and millions of miles apart from each other. But if you were to consider Mars in this instance kind of a pointer to parts of the moon as it goes behind it, it is heading towards and around where the Artemis mission will land one day, Artemis 3. They're going to explore the southern region of the moon because there are some craters there at their farthest depths. They've never been exposed to sunlight, and it makes for some of the coldest temperatures in the solar system, and it also allows for water to stick around, whereas other parts of the moon, you won't find water at the surface. In these deep craters, you will find water, and that's very important because if you find water, in this case, it's critical for fuel. You can make rocket fuel if you find water on any planetary body out there, and that's the same for Mars. And of course, it's a life support system too, and more largely, you think about the search for life as well. But in this instance, it is more related to producing rocket fuel on the moon itself. So that is very exciting, and that's what they're going to the southern region for. So they haven't selected a main site yet. There's a lot of candidates down at the South Pole, but they have not made their selection. For those that are just tuning in, we talked a lot about Artemis earlier and the progress of that mission. And with the Orion spacecraft that is currently in orbit around the moon, heading home soon. And it should return, it should land back here on Earth on December 11th. So it's been a very successful mission. Again, uncrewed, no humans aboard this one, but it is the spacecraft that will carry humans to the moon. So we're really looking forward to Artemis 2, where they'll go in orbit around the moon for the first time since the Apollo era, and then Artemis 3, where they will land on the moon for the first time since 1972. So it's a very exciting program, and since I have it here, I will mention once again, anyone that's tuning in from earlier has already seen it, but if you're able to attend the Holiday Horizons program, which is our holiday event, which you can attend on either this Saturday or the following Saturday. It's going to have a bunch of activities. It's targeted at families with kids in grades K through 5, so we'll have a lot of fun things to do. But on top of that, we're also giving away, in celebration of the landing of Orion happening just around the holidays here, we're giving away some Orion ornaments. So let me hold that up. There we go. This is a 3D printed scale Orion ornament, and you can see there's some good detail on it. This is in its landing configuration. All it's missing basically is the parachutes. Oh, I'm realizing my camera's trying to track it here. Let me turn that off. Just we don't have to worry about it. So it has some decals on it for NASA. And over here we have the Artemis 1 decal. And back here we have the Artemis program logo. So that's an ornament sized for a full-size tree. And we're giving one of these away at each session. So when you come in for Holiday Horizons, you'll get a ticket, and that'll just be it's a free ticket, so no worries there. You just get it for attending, and we'll just pick it at random and announce the winner at the end of each session. So one family will go home with a full-scale ornament. Every family goes home with a small scale, more an ornament sized for a mini tree, like a tabletop tree. And that one is you can take home and decorate too. So every family goes home with one of those. And then this one is the pre-decorated one for your big tree. And the reason why we only have 4 is because one, we printed these in-house, so to speak, and decorated them, and this all takes a fair bit of time. So it is a handcrafted, well, not entirely, 3D printed and then hand-painted ornament that we made here at Kopernik. I'm realizing my camera pulled up a little bit. There we go. Let's readjust this. All right. So you could put a hook on for the tree on a parachute. Oh, that's a great idea. Oh, that's very nice. Not something we have planned for this one, but if you have that capability at home and you get this ornament, that's a very nice idea. It would look really cool. I think Orion has, when it lands, it's going to have 3 parachutes that shoot out, and that would hang probably pretty nicely on your tree. We're sort of turning this into a bit of tradition. Last year we did James Webb ornaments. We're kind of highlighting the mission of the year. Now, James Webb, of course, bled into this year, too. I mean, we got actual data back this year. So there's a lot to celebrate there as well. But Artemis 1 just happened to be closer to the holiday season, so it seemed to make more sense to do this one again. But we had 3D printed James Webb ornaments last year. And this year we're doing Orion. So we'll maybe see what next year brings. They're quite a bit of fun to do, though. So how are we doing on time? It is 11 o'clock, and around 11:10, reemerges. You get a Mars rise on the moon. And that will be the end of our area's occultation. Now, when this video posts after we stop the stream, I'll make sure to break it up like I usually do into chapters, so you can skip through the different points, introduction. And we had a really nice presentation, if you're just tuning in, from one of our Kopernik Astronomical Society members, Sasha, and she covered Martian geology. It's a great presentation. I really recommend you look for that posting afterwards. I mean, you could even go back in the video now and watch it if you wanted to. But I'll have it as a chapter that you can go and click to, so you can learn about some of the geology on Mars. And a lot of that data, as you'll see there, is from all the robotic explorers there, and there have been many over the years. There's 2 active ones that we have right now, Percy, and that's short for Perseverance, that's the nickname, and then Curiosity. Those are the active rovers. They only just lost, they just shut down InSight. InSight is the lander, not a rover, but it's a lander very similar in design to the Phoenix lander from 2008. And that one was studying Mars quakes, these very faint little quakes that happen on Mars, and you got to call them Mars quakes, right? They're not earthquakes. So that one pretty much completed its mission, though. So it was time to wind that mission down. Then there was 2018 is when they finally lost Opportunity after 14 years. Opportunity survived on Mars. Brilliant rover. Not as big as Curiosity and Perseverance, but good, maybe arm's length rover. A bit smaller than that. But that was a terrific craft. And compared to even Spirit, I think was lost after 6 years in 2010. They were twin rovers that landed around the same time, but Opportunity just kept going. And in fact, it was that global dust storm in 2018 that caused some major issues for Opportunity, particularly with its power system. Those Martian dust comes through. If it covers up those panels too much, or the rover itself even, it can't recharge, and that's the end of it. Whereas Percy and Curiosity, which actually was there at the time, Percy landed in 2021. Curiosity landed in 2012, so it was there with Opportunity active on the planet. Curiosity could still actually even move around and perform some tasks during the global dust storm because it's a nuclear-powered rover, powered by plutonium, a nuclear power system, rather than solar energy. And that's just due to the sheer size of Curiosity, and Percy's the same way. So some brilliant robotics out there in the solar system and on Mars, and it's only going to get more exciting from here with some of those missions. Our robotic explorers are a critical part of space exploration. And there's some really amazing ones that are being worked on through various agencies, space agencies across the world. There's a lot of collaboration happening with the ESA and the CSA. Those are the European and Canadian space agencies, as well as JAXA, Japanese Space Agency. So it's great to see that international level continue. I mean, there's a lot of that happening with Artemis too. I should say Artemis also, not just Artemis too. but a lot happening there, prepping the space station, the Lunar Gateway. That's a big international effort in addition to the International Space Station. Yeah, some of the outer solar system robots they're sending out there soon. I say soon, in the next decade or so. You've got the one going to Titan called Dragonfly. That one's going to be a brilliant mission. Actually flies around in the atmosphere of Titan. That's a moon of Saturn, Titan. And then you have Europa Clipper. It's going to get nice and close to Europa, studying these moons, these icy moons of the solar system. Some of them prime candidates for the search for life. So the more we send out there, and if more than that, if we find life in our solar system beyond the Earth, that bodes very well for what we might find out there deeper into the galaxy and universe if we are able to ever venture that far. So it is 11:07. Let's zoom in on Mars here in Stellarium. And yep, just starting to appear. And that motion that you're seeing there is primarily driven by the moon itself. The moon moves through the stars, the stellar background, to a noticeable degree throughout an evening. You can easily measure that. Not as easily to do, or it's not as easy to do with the planets themselves. But the moon is the motion is driven by its orbit around the Earth, and so you can measure its change day to day. It happens pretty quick. I think that's the south polar ice cap we're seeing there in the view, because the north polar ice cap is much bigger, and I think Stellarium earlier I saw was doing a good job of simulating that. All right. Well, yeah, as we continue to at least enjoy a simulated view due to our cloudy skies here at Kopernik, and just imagine, we're using our imagination and also using the other live streams that I mentioned earlier to help guide us as to what this would look like in our sky. Yeah, I want to thank everyone for tuning in. We're not winding down quite yet, but if you are in a position to support Kopernik for future live streams like this one, there is a donation button in the live chat, and you can contribute to our year-end fundraiser that helps support Kopernik staff, our virtual programs, and helps us to grow. Earlier I mentioned how we did make some big upgrades to our space science lab here, which is where I'm streaming from, and those upgrades will benefit both our virtual audience, like you, and our in-person audience for our in-person programs too. So we're very excited about that, and you'll see some of those benefits start to come through. And in part, that's because of the kindness of our donations, and with the help of some grants as well. So thank you for that. There's also a PayPal link in the video description if that's your preferred platform. Either of those are just fine options. But otherwise, you can of course support Kopernik by subscribing to our YouTube channel so that you can stay informed about the latest developments in astronomy and beyond. We cover a large range of topics. So it's a great platform to get your weekly dose of science on Friday nights, especially with our STEM presentations. And if you liked today's video too, you can of course hit the like button, and that helps show your support there as well. let's get a little wider field view here in Stellarium. So occultation is over for our area. If the clouds cleared for us and we went out, we would just be seeing a conjunction. So it's moving past that occultation phase. But this is perhaps the more interesting one anyhow, because this is a point, if we had clear skies, we'd be seeing the moon and Mars in the same telescope simultaneously. So you might catch the craters on the moon and then switch to Mars, and you can see the surface details there like the polar ice cap. Again, just out of curiosity, I am going to take another look outside just to see if anything has changed for us. It's been pretty consistent tonight with the clouds, but you never know. All right, yep, and I am sad to report no change. Cloudy skies for us. Saying earlier that we have pretty bad luck, it seems, with these conjunctions. About 2 years ago now, on December 21st of 2020, there was a Jupiter-Saturn conjunction. And it was a similar case there where it was just consistently cloudy. And this was also just after our huge snowstorm that happened that year. So I remember our director, Drew Desker, went through all this effort to clean off the dome, and it's a little bit of a hassle, and I'm very happy he did that and thankful for it, because it at least gave us a chance, because otherwise there was like over 2 feet of snow on the dome. So what I'll do now... Oh, Linda asks, would moon glare obstruct view of Mars? Yeah, you would have to get the... You probably, ultimately what you have to do is switch between the exposure of Mars versus the moon. And this, I saw this on Griffith's stream, or maybe use a moon filter, which I think we saw on another stream too. That might have been Ray's astrophotography, I think. Otherwise, if you're just directly looking at it through a scope, the moon's going to be way overexposed when you're exposed to Mars. And when you're exposed to the moon, Mars is going to be too dim. So you could probably find a midpoint where you get some detail on both, but neither of those views would be ideal. So, great question. All right, I will do one final call on questions here for this evening. So I'll give you a moment here. If you have a question, type it in the chat, and we'll conclude the stream with those. We'll save our energies for any future Mars observing we might be able to do during the close approach window. Do a wider shot here. Yeah, my original plan for this was to do wide field and a more narrow field capture with a planetary camera. So you'd get the detail on the two different objects, but you'd also see the conjunction play out. And then I was also thinking about putting together some time lapses for that too. That's usually, if there's a chance to do a time lapse and it'd be interesting enough, we always like to follow up with that the next day. We've done it with the lunar eclipse streams, and I think the solar eclipse as well back in 2021, I think. June of that year. So that would have been interesting as well. All right, well, I'm not seeing any questions come through. So I think that's a wrap. So yeah, and again, thank you for tuning into Kopernik's attempt at a coverage of the Mars-Moon conjunction. It's a part of this field, you know, unless you're in a space telescope up there, even those on the astronauts on the ISS, you are constrained by the sky itself and the weather conditions out there. So we'll look forward to our next batch of clear skies, maybe covering this close approach of Mars coming up soon here. And look out for other ways to interact with us. If you want to hit the notification bell on YouTube, that will alert you on your device when we go live, especially for the more impromptu streams where we're like, oh, we have clear skies, and we didn't schedule it out, you know, a month in advance. So yeah, again, thanks for tuning in. Like the video, subscribe to the channel if you're not already, and we will see you on the next Kopernik live stream program. Have a good night, everyone.